Hello everyone, welcome to 3 classes. So today we are going to study about transport in plants. So in this topic, we are going to deal out with some important terms like osmosis, osmotic potential and osmotic pressure. So let's get started. Osmosis. What is osmosis? It is the movement of solvent from a region of higher concentration or higher water potential to a region of lower concentration or lower water potential through a semi-permeable membrane. So as you can see, there are some terms written in red. Okay, so these are very important that you need to keep in your mind. Okay, you don't have to remember the whole definition. If these terms are there in your mind, you can easily answer. So it is the movement of solvent from a region of higher concentration or higher water potential to the region of lower concentration or lower water potential through a semi-permeable membrane. So if I'm saying semi-permeable membrane, okay, what does it mean? Membrane can be of 3 types: permeable, impermeable, and semi-permeable. If I'm saying semi-permeable, try to get it from the term itself. Semi-fluid. If I'm saying semi-fluid, what does it mean? Semi-fluid means partly solid, partly fluid, not completely fluid. Okay, it is partly solid, partly fluid, just like jelly. Okay, similarly, if I'm saying semi-permeable, means it is not totally permeable. Okay, it is partly permeable or partially permeable. Okay, so you can imagine it in this way. For example, imagine there is a home. Okay, there is a home. एक नया घर बना है, उसमें कोई डोर नहीं लगा है अभी तक. एक घर बना है जिसमें कोई भी डोर नहीं लगा है. तो उस घर के अंदर कोई भी जा सकता है, उस घर से बाहर कोई भी निकल सकता है. ओके, इस घर के अंदर कोई भी घुस सकता है और उस घर से बाहर कोई भी निकल सकता है, क्योंकि वहां पे कोई डोर नहीं है. ओके, सो इट इज इनफॉर्मेबल. ओके, कोई दरवाजा नहीं है, तो कोई भी अंदर जा सकता है, कोई भी बाहर आ सकता है. देयर इज नो डोर इन दैट पर्टिकुलर होम. ओके, इट इज अंडर कंस्ट्रक्शन, so anyone can easily enter and anyone can easily exit. Okay, so that particular membrane is what? It is permeable. Okay, permeable means giving permission to someone. It is permeable to all the molecules, that particular membrane. You can imagine that particular home, it is permeable to everyone. Anyone can enter, anyone can exit. If I'm saying permeable membrane means it is giving permission to all the molecules. Any molecule can enter, any molecule can exit. If I'm saying semi-permeable, semi-permeable means you can imagine in this way. एक घर है जिसमें डोर है और उस डोर को हम अपने हिसाब से खोलते हैं और बंद करते हैं. तुम्हारे घर में जब कोई गेस्ट आते हैं जिन्हें तुम जानते हो, जैसे कि तुम्हारे कोई दोस्त या फिर कोई रिलेटिव, इन दैट केस यू आर गोइंग टू ओपन द डोर. बट अगर कोई ऐसा इंसान है जिसे आप नहीं जानते, इन दैट केस व्हाट यू आर गोइंग टू डू, यू आर नॉट गोइंग टू ओपन द डोर. ओके, so that is what called semi-permeable. Means we are giving permission to particular or certain person to enter. We are not giving permission to everyone. Okay, it's not like that anyone can enter into my house. Okay, only my friends, my relatives, they can enter. So in that case, you can imagine that home where there is a door and you are going to open that door for some particular person, not for everyone. In that case, that particular home is called what? It is acting as a semi-permeable membrane. It is selectively permeable or semi-permeable. Okay, so it is only allowing certain molecules to pass through it and certain molecules to exit. Okay, all molecules they cannot enter, all molecules they cannot exit. So it is all about semi-permeable membrane. If I'm saying impermeable, okay, impermeable means what? Impermeable means there is a home with a door and the door is locked, so no one can open it. Okay, no one can open it. So none of them can exit the room, none of them can enter. Okay, घर के अंदर जितने लोग हैं वो वहीं पर रुकेंगे और घर के बाहर जितने लोग हैं वो घर के अंदर नहीं आ सकते, घर के अंदर जितने लोग हैं वो बाहर नहीं जा सकते. I hope it is clear. So this particular home, it is acting as an impermeable membrane, which is not giving permission to any molecule to enter into it or to exit. Okay, so now there are some other terms. High water potential. So what is water potential? I am going to make another YouTube session for this water potential, but for today, for your better understanding, I'm just going to explain it in a brief way. Water potential means what? Try to guess it from the term itself. Water potential means it is the potential of water, or you can say it is the potency of water to move from one place to another. If I'm talking about pure water consists of what? Pure water consists of free water molecules, and they have very high kinetic energy, and they have a potency to move from one place to another. So they are going to move from what to what? They are going to move from high water potential to lower water potential. Or else you can say where the water concentration is more to the place where the water concentration is less. Okay. Now there is another term, solvent. What is solvent? I think you might have heard about it, you might have read about it in your lower grade, like in 9, 10. So if I'm talking about solvent, we can take a very small example. If I'm saying salt water, then salt water, salt is the solute and water is the solvent. Okay? So in osmosis, always remember one thing, it is the movement of solvent we are talking about. The water molecules, they are moving, not the solute. So you have to remember the movement of solvent from a region of higher concentration, means where the water molecules are more, or where the water potential is more, to the region of lower concentration or lower water potential through a semi-permeable membrane. What is semi-permeable membrane? We have already discussed about it. Or you can also define osmosis in another term, like the movement of solvent from a region of lower solute concentration to a region of higher solute concentration through a semi-permeable membrane. So what is this lower solute concentration and higher solute concentration? If I'm talking about water potential, as I said, water potential means what? It is the potential of water to move from one place to another. It is the potential of free water molecules to move from one place to another. Just imagine there is pure water. In case of pure water, all the water molecules, they are free. They have very high kinetic energy and they can move from one place to another. If I'm keeping if I'm taking two glasses, okay, in one glass, the level of water is more, and in other glass, the level of water is less. And if I'm going to connect these two with some pipe or any kind of tube, you will observe that the water will move from the glass which consists of more water, or where the level is more, to the glass where the level is less. But if I'm adding some solute to that pure water, when I'm adding some solute to that pure water, what is happening? The free water molecules, they are going to interact with the solid molecule. So now this free water molecule, they are no more free because they are interacting with the solid. So as a result, what will happen? You are going to get very few free water molecules. You can imagine in this way, like आप घर में अकेले बैठे हो, बोर हो रहे हो, you have no one to talk to or you don't have any work. In that case, suppose आपके किसी दोस्त ने आपको कॉल किया और पूछा कि are you free? Are you ready? Like, can we hang out? In that case, your answer will be yes, I'm ready. But just imagine one scenario where you are not free. Okay, there are some guests at your home. You are interacting with them. You have a lot of work. So in that case, if one of your friends will call you and ask you, are you ready? Like, can we go out? In that case, you are going to say, no, I'm not ready. I have some work. So that similar thing is happening. So when there is pure water, all the water molecules, they are free. They are free to move from one place to another. They have very high kinetic energy. When I'm adding some solute, in that case, what is happening? The water molecules, they are no more free. They are going to interact with the solid molecules, and there will be very few water molecules left which are free to move from one place to another. So when I am adding some solute to pure water, in that case, what I'm doing, I am reducing the osmotic potential. Okay, I'm reducing the osmotic potential. So now what is osmotic potential? We are going to read about it in our next slide. I hope it is clear. The movement of solvent from a region of higher concentration or higher water potential to a region of lower concentration or lower water potential. Higher water potential is more. That means water potential is more. So when I'm talking about pure water, always remember one thing. In pure water, the water potential is highest. That is 0. Okay. So if someone will say higher water potential, that means that water is pure. If I'm saying lower water potential, that means I have added some solute to that particular water. Okay. So higher water potential means what? Higher water potential means low solute concentration. And if I'm saying lower water potential, that means high solute concentration. And low solute concentration is otherwise known as hypotonic and this high solute concentration is called hypertonic. So we are going to study about these terms in our next session. But for now, just remember this is the definition of osmosis. You have to remember this all those things which are underlined in red color. You can see this. You can see this. This is a semi-permeable membrane, which is selectively permeable. It is going to allow only certain molecules to pass through it. You can see this is the pure water. This is the pure water, and here I have added some solute. So in this case, what will happen? The water potential will be low. Here the water potential will be high. So as a result, you can see what is happening. So the water is moving from higher water potential to lower water potential. So you can see there is an increase in the level here. There is an increase. There is an increase in the level in this case because the water is moving from higher water potential to lower water potential. I hope it's clear. Now let us move to the next part. Osmotic potential. What is osmotic potential? So what is water potential? It is the potential of water molecules to move from one place to another, like from higher concentration to lower concentration. When I'm adding some solute to that pure water, what is happening? The water potential is getting reduced. Or else you can see the tendency to move from one place to another, the tendency or the potency of water molecule to move from one place to another, that is getting reduced. Okay, because the free water molecules, they are doing what? They are interacting with the solid particles that I have added. So what is osmotic potential? It is the potential of water molecule to undergo osmosis. So when I'm adding some solute, what is happening? That potency is getting reduced. So you can say when I'm adding some solute, the osmotic potential is getting reduced. So osmotic potential is also known as solute potential. It's a component of water potential. It is always represented in negative. Why? Because as you know, what is the water potential of pure water? It is zero. When I'm adding some solute, then it is doing what? It is reducing the potential of water molecules to undergo osmosis. That is what's called osmotic potential. So if I'm saying less than zero, that means the value will be in negative. So it is always negative and it is represented by psi S. The osmotic potential or solute potential decreases with the increase in solute concentration. Okay, I have already discussed about it. When I'm adding some solute to pure water, what is happening? The osmotic potential, that is the potential to carry out this osmosis, the potential of water molecule to undergo osmosis, that is getting reduced. The osmotic potential or water potential is inversely proportional to solute concentration. What is this inversely proportional? I think you have heard about this term in physics, in chemistry. So what is inversely proportional? Directly proportional means if I'm increasing one thing, the other thing will increase. But if I'm saying inversely proportional, that means when I'm increasing one thing, the other thing will decrease. So here, when I'm increasing the solute concentration, the osmotic potential is getting reduced. Hence, we can say osmotic potential and water potential is inversely proportional to solute concentration. So this is very important. Please keep these things in your mind. Now, let us move to the next part. What is osmotic pressure? Students mostly get confused between these two terms, osmotic pressure and osmotic potential. बहुत सारे बच्चे बहुत देर तक, even you can check out, like you can see graduation student, post graduation student, even after that also बहुत बच्चे यहाँ से कंफ्यूज होते हैं ऑस्मोटिक पोटेंशियल और ऑस्मोटिक प्रेशर. सो ऑस्मोटिक प्रेशर क्या है? इज ऑस्मोटिक प्रेशर एंड ऑस्मोटिक पोटेंशियल द सेम थिंग? लेट अस फाइंड आउट. ऑस्मोटिक प्रेशर क्या है? द प्रेशर अप्लाइड टू स्टॉप ऑस्मोसिस. The pressure applied to stop osmosis is called osmotic pressure. Okay. What is osmosis? It is the movement of water molecules from a region of higher water potential to a region of lower water potential through a semi-permeable membrane. That is what's called osmosis. What is osmotic potential? The potential of water molecule to move from one place to another, that is called osmotic potential. So what is osmotic pressure? It is the pressure that we are applying to stop osmosis. That is called osmotic pressure. As you can see in this diagram, as you can see this in this beaker, there is a sucrose solution, and here there is pure water. So can anyone please tell me in what case the water potential will be more? The water potential in case of pure water, it will be more. I have already discussed about it, that the water potential of pure water is 0. It is the highest. So water potential of pure water is more. And if I'm talking about this, here I have added some solute to that particular water. Here the solute is sucrose. So here what is happening? Here the water potential will be less. And all of you know that water always moves from higher water potential to lower water potential. So what will happen? The water inside the beaker will enter into the funnel. Water inside the beaker will enter into the funnel. You can see this is the funnel. Okay, so water inside the beaker will enter into the funnel. This is the funnel, okay, which consists of sucrose solution. So water will move from this beaker into the funnel. Why? Because the water potential here is more in comparison to this. Here we have added some solute, so water potential is more. So you can see the water will move. So as a result, what will happen? The level will increase. If the water will move from this beaker into the funnel, what will happen? The level of water will rise in the funnel. But here I'm applying some pressure. I'm applying some pressure to stop that osmosis. Due to osmosis, the water is moving, right? The solvent molecule, the water, which is the universal solvent. The water is moving due to osmosis, right? If I'm applying some pressure to stop it, that is called what? That is called osmotic pressure. You can see there is no increase or no rise in the level of the water inside the funnel because we are applying some pressure against it. We are applying some pressure against it. So this is what's called osmotic pressure. I hope it is clear, all of you. Just much for today. So if you like this session, please do like, share, and subscribe to my channel. You can see these are the links provided here. You can join my Telegram channel. You can join my WhatsApp. You can mail me in my email. Okay. So this much for today. And we are going to discuss about water potential in the next session. All of you, please take care. Bye, everyone.